So good evening. Hope you're all doing well. I'm really pleased to have our potable water discussion this evening, and I wanted to introduce our three speakers. And then when they're all done towards the end, I can do classroom-related announcements, but they're eager to get started. And so the first speaker you will remember from our previous talk is Peter Lee, who's going to he's been in independent consulting for 35 years, and he's worked in many of the peninsula and other cities on many of their water issues. Another individual we have is Mr. David Norris over there. And David has been also doing independent water consulting for the last 15 years. And then 20 years, you can give more of your history, but then there's another 20-year period before that. So he's got a lot of experience as well, years of experience. And then finally tonight we have Mr. Paul Lord, who's with the Marina Coast Water District, thank you, MCWD, where he's the water conservation specialist, and he's been there for 8 years. And before that, he's worked in other areas of the peninsula as well, doing related issues. So we look forward to hearing from all of them. We may have Mr. Dirk Medema coming back. We may not. I thought he was going to be here, but maybe not. So, but I'll let you go ahead and get started, Peter. And welcome.
Yeah, good evening. I'm going to talk to you about the Marina Coast Water District potable water system. I was thinking about talking about the city solid system, but this one more relevant here, and it's better for you to understand. I run from the production from the well on the way up to your building, your dorm here, and then talk about the water district customer and the pipe and the tank and the booster pump station, and go a bit beyond into the ground aquifer and saltwater intrusion, and after that Dave Norris can talk to you about the replacement of the pipe and infrastructure. So I hope you all download the HO2 app in your cell phone. There's a quiz at the end here, and it counts 25% to final grade. So if you haven't done it, you can download this. It's very good for tracking your water use and water consumption. And you can go to the Play Store and download it. I have one of them. Okay, this one I have a simple system for you. So we drill the well down to the deep aquifer and pump the water up to the pump station here. We may add some chlorine into disinfection and pump it to the reservoir. So have enough pressure into your dorm and pump along into the underground pipe. That's fire hydrant for fire purposes, and go into the homes and the businesses. So that's the simplified. That's how the system works. So Marina Coast Water District formed in I think 1969, serving city marina, and then after the Army left, we contract with for serving the four-door property, and you have CSUMB here and your School Nova Frederick Park housing over there. So this is the area city marina four-door here. We have a couple three well in marina and a couple of well here and the new well Watkins Road. And this one, and we serve it on the way to the Seaside Golf Course and the housing near the Seaside High School, on the way up to here and up to the beach. And so the water comes from the two dams here, run along the Salinas River, Arroyos River, and then it's have the infiltrate into have the aquifer underneath. That's why we pump the water to serve the consumer. So here's the roughly the arrow of the Salinas Valley aquifer. That's where the farmer pump up for their crop and marina pump up to serve the city marina. And here is the, we call the pumping at the 180 foot aquifer too much, so the salt water intrude into the aquifer, and it goes very fast, and then people have to stop pumping at the 180 feet and to 400 feet, and go deeper down to 900 feet aquifer, and you see how it slow down here, slow down, and no, we cannot use the 400 foot anymore, and the farmer in Cassville, they stop pumping for their crop too because it's too salty. So this one, the mill as well, working well, 2,000 gallons per minute and 675 feet below ground, well, 3 years ago. And now the well, 2,000 gallons per minute. You see how deep it goes, 1,010 feet below ground to get the water. And you see the standard pumping station, and here the piping, and inside I'll show you later. So every well we have the standby generator just in case the power off, and it will turn on and keep pumping, so people have water. And this one is the Mill D zone 10 to 2 million gallons. You can see up for the hill up here. You can see it up there. And next to it be the push the pump station. The smaller one is just enough to be pressure enough. Say you live on the 3rd floor of your dorm, you have to have enough pressure for you to take a shower up there. And the bigger pump here, need for when in case they are farm, the pump they need a lot of water, like 3,500 gallons per minute to put out the fire. This pump will turn on and supply the water for firefighting purposes. And you see the terrain there is it's up the hill and down low, and I have a map here to show you the pipe, and there's 6 pressure zones, from 200 feet down to up to 510 feet. So different zones. So every time you go you have to reduce the pressure to the pressure reducing valve here. Otherwise, blow out your piping, the water, everything. And inside the pump station, you have the standard SCADA control. So you sit in the office, you can turn the pump on and off, and you see how much pumping and how high is the water level in the tank. So this one inside the pump station, you have the electrical panel, and you have the SCADA panel in here. And here here the SCADA system. So the operator in the office, he can look at, say this pump is running and this pump is stopping, and he can see how high the level in each storage tank here, and see the booster pump station, which one running, and if one fail, it's have the alarm, and he can see, and he can also see how much pumping for the last 24 hours, for the last month, last week, and he can print out the report and the data. And in the system it tells you, what kind of pump and maintenance required for the pump, and then the one in charge, he has a laptop too. He bring it home. So say at night sound the alarm him, and he can turn it on and see what's wrong, and he can turn it off. That pump turn it on and switch on another pump, and so that's how we control it remotely. And last time, in addition to pumping, we required to do the testing in marina coastwater trick. The well, I just show you Watkin Gate well here, and here the required to do testing for different kind of inorganic nitrate, different kind of testing required. We submitted to the health department. It's either some tests have to do daily, sample different, go to different house and daily. Some have you have to do weekly, some monthly, some do quarterly, some do you do annually. So the lab will part of function. And some more tests. See, and then some. I didn't have the actual lab, but I took the lab. There are two labs. One is the testing the nitrate, and one do the microbiological testing. So there are two sections. Normally they have two separate labs. You see these do the bacterial test and fatty test, and you do the this here, and you put in the oil, in this fish, and you do find out if something wrong with the water. Okay, let's go to the Marina coast. 2011 data, surveying about 34,000 people, 20,000 Marina and 15 in Florida. Now it's about 40 full-time employees, 8,000 connections, 8,000 meters, revenue about 14 million, expenses about 15. Spend about $5 million per year to put in the new well, new pipe, and we have access now about $150 million in the debt of $46 million. So operate 8 wells, 11.2 million gallons from 8 storage tank, 19 lift stations. That's for the wastewater. That will be the next section here. 223 miles, sewer, 155. 6 booster pump station, 17 standby generator, hydrochloride 4 active water, and 19 pressure reducing valve. Here is the distribution from 2005 to 2012, and Paul will give you the latest information later. You see, it's, so I added up here from 3,800 acre feet per year in 2005, and more or less the same for the last several years consumption. And here is the $4 allocation. We only allow to take 6,600 acre feet from the aquifer, so we cannot exceed this number here, and they allocate, say for marine about 3,350, and different agencies have a different allocation. And the green one is the unused allocation, and here you set CSUMB. You have about 1,000 acre feet per year, and you use only so far about half of 450. And here the Army was 1,600, and they use only a couple hundred. So what does it mean? So I'm telling CSUMB and the Army here. So whatever you don't use here, why don't you lease it to other people here? Like seaside, you don't have enough. So you lease out this amount of water from your portion, and you can have revenue for yourself. So you can use the money, and whenever, probably 50, 75 years from now when you need it, and you can get it back later. So instead of some other people, they don't have enough. And they have to find new salt water, which is very expensive. So that's my proposal. You lease out this portion here to other people, and you get revenue. It's better for everybody. And David, go to top of the money. So here give you some idea of what money we spend every year, to put in the new well, new tanks, new pipelines. So from 2008 to 2012, and so it's commercial project. We spent about 20 million and hasn't produced any water yet. It's failed. And if you read on the newspaper, you have some idea. But the biggest problem is the oil community here, because the army, over 50 years, they haven't replaced their infrastructure. And now you're coming in, and all the pipe broken down, everything didn't work. So a lot of money have to spend to upgrade the infrastructure. What does it mean that you guys have to pay a lot more? Everybody have to pay more for water and sewer collection. See, I show you some of the pipe here. It's on 50-year-old broken up, rusting, broken up all the time. Sometimes all through the trees. We have to spend probably 100 million to replace all the old pipes. So let's talk a little bit about the rate. We collect the rate for operation maintenance, and then put in the new infrastructure. For marina rate is very cheap. Only pay $9 for the sewer a month, and average about $50 for water. I think it's the cheapest in the Montreal County. But even back there it's real cheap. Before, when I moved to marina, I pay my total water and sewer only about $19 a month. It's coming up. Let's go to the border area here. You see how big it's jumping up. Jumping up from compare $50 and now in the 4-door, I pay about $75 a month for water, and then $32 for the sewer collection. And you see the $5 difference here for the water. The surcharge here we collected to put in the new well and new tanks, new booster pump station. And this one $20 surcharge is replace the old broken pipes, and then a lift station. And that's one I showed you before. So here is the catchment area I showed you before for the Salinas River, and here is the you see how small it is for the Carmel River, very small, and they have to supply a lot of people down in the peninsula. That's not enough water to supply. And I show you the seawater intrusion. And here the seawater intrusion is upper Castroville, Marina, Salina here, and some other. You mentioned about the nitrate last time along here. Contaminate the well supply to the farm worker. Need to replace the well. And then here some dissolved solid and some arsenic out here. And then so the county have I think probably 100 million to try to improve the potable and the water for the farmers, and then they put in increase the dam height to get more storage to them, and put in the rubber dam here, and then using the recycle to supply to the farmer in Castroville for the strawberry and artichoke field up here. So this one, the diversion here, I think $60 million cost. For sure, this Castroville, I think $40–50 million, and the two of them, I don't know, probably $20–30 million so far, but it's still not enough because the peninsula still needs more water for their use. Here I show you the Carmel watershed here. Very small area. And you see in the state only allow them to be about 3,700 acre-feet a year. draw from 11,000. After taking out from the Carmel River, violate the order. Now they have to build a desal to supply because the state will shut up in 2016. Shut up. They cannot come over this limit anymore. And so that's what they propose is the new desal plant, taking out from the water near the beach here in Marina, pump it into the treatment, the desal plant here, and then pump it down to the seaside and then concrete to supply the water. So that's all I have, and I have the map here if you want to see the system with the well and the pump, booster pump station. You can have that, and then that's all I have. And you can ask questions later.
Sure. Yeah.
Let David.
Go next.
Yeah.
Thank you.
I might need some coaching on
Yeah, we're going to need some coaching on that.
I just have that folder with some photos, so I'm thumb drive. Reconstructed high school teacher, but that was back in the days when we used chalk. It's a little different.
Yeah. There you go.
Maybe I can learn. And then I just hit the arrows. And then that's the chalkboard over there. So if I want to write something,
You can actually write on this too.
oh, okay.
We had discussions about that.
Oh.
I have markers you can use if you need to.
Okay.
We can turn off that and you can write on there if you'd like. That's not a problem. Just let me know.
That one there. There we go.
Oh, good, I like photos.
Okay, there we go. So that's good. Then I just toggle it. I can just toggle through one at a time like that. Yeah, there we go. Well, just Lee or Lay? Lay. Mr. Lay talked about the big picture of costs and millions of dollars a year to put stuff in, and he touched on something that I'm talking about. What I do is I replace stuff. I'm a civil engineer. I design kind of day-to-day replacement projects because this stuff, even though it might have been put in, well, some of the pipe in water systems across the country was put in 100 years ago. Most of the pipe in the United States has been put in the past 100 years, and so a lot of that pipe, like 30 to 40% of it, is ready to be replaced right now. And if you just take the cost of what is estimated that countrywide needs to be spent to replace that pipe, I'm talking about the buried stuff just so we can have what we have now, not improve it, just to keep running in place. It's about $1 trillion nationwide between now and 2025. So it's a huge amount of money. So what I get involved in is just day-to-day replacement projects. Maybe something isn't working right. Maybe we need to increase the size of the main to provide fire flow. Mr. Lay showed a picture of a pump station, which was a really good example. He showed these little pipes. He said that's enough water so you can take a shower with. And then these great big monster pumps that are about 5 times the size, and those are to put out the fires. Now, the fires happen once every 5 years maybe, but you have to size the pipes in the pump stations to deliver the current standard of fire flow protection. So, you know, where a 4-inch pipe might serve 2,000 people, you've got to put in an 8-inch or a 12-inch pipe just in case there's a fire so that you can get 3,500 gallons a minute fire flow. So those are the kind of standards that we have come to accept here in the U.S. And it's, well, those are the standards and we pay for it. So anyways, what I'll show you here, this is just one valve replacement. You might recognize the location, Beverly's Fabrics. It's on a 12-inch main in Seaside. This is the shift where they actually go in and replace the valve, where the contractor comes in and replace the valve. But before that, they had to plan when they could shut the main off, because you gotta do it with the main line. So you gotta shut the whole main off, so you gotta figure out who you're gonna put out of water, and hopefully you can find the valves, and you can shut the right pipe down, because sometimes the records aren't very good. And so you gotta have your crews out there maybe for a couple of days in advance, scheduling, getting out there, and then you schedule the crew to come out at midnight, because that's when the water demand is low. So, okay, so you bring over, instead of the cooler, they're planning their party here, this is the generator so they can run the dewatering pump. There's the old valve. This is just to replace a valve so we can do some work and operate the system for the aquifer storage and recovery program. There's a new valve, somewhere between $1,000 and $2,000. There's the pit. That had already been excavated, and the concrete cut excavated everything. Guy climbs in there with a chainsaw, starts cutting out the pipe. You notice the water comes spraying. This is not fun work. Standing there knee-deep in water, and the water comes up when he finally opens everything out, and it starts pouring. So he gets out, so that in case there's any risk of it caving in on him, so he jumps out until the pumps can pump the water down. This is with the valve fully shut off. This is actually a good shutdown, because the valves get all gummed up, and sometimes it doesn't work that way. So you can see waving my hand around.
When you say valve, you're talking about a different valve that shuts it off? Or?
Yeah, you've got to have a valve on each side. So you've got to find valves, and hopefully they're close enough together so that you don't put the whole city out of water.
Okay.
So yeah, so you've got to isolate that section of pipe. So. And somehow I lost the.
Oh, the light?
There it is. Oh, I see. I pushed there. Okay. Anyway, so there you see the water pouring out there. So. This is the old valve. The pipe is actually surprisingly in good shape. I mean, there's not a lot of gunk in there. For the ones Mr. Lay was showing were. Those were kind of the ones we see a lot of times. But you see it was inoperable. It was completely rusted over on the top, so it wasn't any use to anybody. So there's a new valve in, and the pipe up above is just so that you can go over the operating nut for the valve. I'm using, there it is right there. That's the thing you put the handle on so you can turn it. And then you have to replace the pavement, which they're doing. And this is just a patch. They've got to come back and do the finished paving on the street, but this is just so you don't have cars going into the trench the next morning. And then you clock off. So that's one shift to replace one valve. And I didn't look at the invoice on this one. I was just taking pictures and documenting everything on that particular job. I would guess it's somewhere between $5,000 and $15,000, well over $5,000 for that amount of work. So probably closer to 10. I don't know if you have any comment. Between 10 and 12 something. So my point is it's not cheap. Okay. Here's an above grade pump station, an old pressure tank. This is one of these little satellite systems. The pipe here is plenty big enough to supply the 10 or 15 homeowners that are there. But you need bigger pipe to supply fire flow. This one was just an upgrade because there are all sorts of leaks. The tank it's a high pressure tank, and you've got rust on it. You see this high quality foundation work. This was a system that was acquired by my client years ago. It was a small water system that serves a small homeowners association, and it was purchased by them. And so then, like what Mr. Lay was saying, when they took over the Army, you've got a lot of really junky stuff that these people didn't take care of, and then you have to figure out a way to charge ratepayers to fix it up. So, and then, of course, you also have to fix it up. So that's what we're doing is. So, but before you do that, you have to replace the pipe, the connecting pipe on the suction side and the discharge side of the pump station. So you can hook it up on. Now this has to be done when everybody's out of water. There's only one main serving everybody. So you got to notify people, and when you're in particular parts of the Monterey service area, you have some very cranky, entitled people who, get all upset and throw their attorneys at you if you just walk by their house and make their dog bark, let alone turn their water off. So, anyway, I won't get too political on that, but sometimes it's a challenge just to try to help people out and fix their pipes for them. So anyway, so the water off, and these guys are running like mad to try to tie everything in. You've got to go back until you find some good pipe to cut into. Just like if you're remodeling your bathroom, you don't put in a nice new tile bathtub on a rocky floor. You keep going back until you hopefully find something good back there. Okay, so now the water's back on. and we've got the pipe stubbed out here. But we had to have the old pump station still running, and the old tank still there while we're doing all the rest of the stuff, because you got to keep people in water. Then we hook up the new pump station, and we have to flush it and do bacteriological tests, make sure it's clean and the water coming out of it is safe, and we test it through the control system and make sure it's reliable. It's going to go on and off when we want, and it's not going to blow any pipes up or stop in the middle of Christmas weekend or something. And then we put in a new, smaller tank. So there's a whole story on that, which I won't bore you with the details, but we managed to downsize the infrastructure to serve them better and cost a little less. And you notice a little higher quality concrete footing with seismic anchors. And then, of course, the obligatory coat of paint. So maybe it'll last a while. So anyways, this is a skid-mounted pump station. So this is a simple upgrade project that we just go from one. Here's another one. We had problems with freeze-ups. This is a slightly different pump arrangement for those who are into pumps. These are like well pumps that you put in the can rather than vertical placed pumps. But anyway, you pull the pump out and you look at that. Well, that was where somebody's drinking water was coming out of, and this is actually quite common. When you cut open a pipe, there's a biofilm, there's a biological growth that grows and mixes with deposits of iron and manganese, and in this case you have fairly hard water, so calcium, and it's pretty ugly looking. Needless to say, we cleaned that out before we put the new pumps back in. But it really doesn't hurt anybody, but it looks pretty ugly, and if it can eventually cause enough bacterial regrowth that you can lose some of the chlorine residual that's in the water, and then when you lose chlorine residual, then people can get sick, and we as people in the water industry don't want to have that happen. So here we're replacing, again, upsizing the pipe below grade, so if we want to hook up a big fire flow pump in the future, we'll have that option. It costs so much to replace a pump station, to go through all this stuff of shutting down the water and getting a contractor out there and digging up everything. I mean, it's a huge project that once you got the ground open up, you just replace stuff. If it's 2 inch, you put it up to 6 inch or 8 inch. Because it costs you so much to put stuff in, you go the next size up. And some people say, well, you're not being efficient, and other people say, well, yeah, we are, because it's going to cost us the whole price again just to dig it up and replace it next year. So anyway, more pipeline replacement. This is actually an okay trench because he's squatting in. It's actually only this high, so it's safe. It's not an OSHA violation. So we replace the suction piping and then obligatory coat of paint. Another one, same thing, old leaky piping, kind of funky, tied together stuff. They put in a new pump a while ago, but the pipe is so small that the pump's just, it's like pushing through a drinking water straw. It's constricting the operation of the pump. So first thing you do is you take one of the pumps and put it out there, and you build a whole temporary pump station just so you can keep everybody in water, because it might take a week to do the rest of the work. And I challenge any, you'll have a lot of fun going and telling somebody, oh, your water's going to be off for a week, folks. It doesn't work that way. We try to avoid turning anybody's water off for even a couple of hours, but every once in a while when you have to. This one we were able to do just with the water. There was enough water in the tanks that we could go hook this up, flush it, take the test on it, put it in service before anybody had to be out of water. So that's the ideal case. This is in a vacation area where it's mostly vacation homes, and there's not a lot of demand in the middle of winter. And then you replace the piping on the suction and discharge side, and then another new skid-mounted pump station slided in. More beautiful pumps. This was a skid-mounted station that we had to work with the existing pump shed, and all our equipment was mounted at the outside of the shed, so we couldn't really just lift the shed up. So we designed the skid, specified that the skid had to be split into 2 parts. So they slid one part in and then slid the other part in. You see the little roller down here, and then they bolted it together. And voila. This is a storage tank, a small, it's not really a storage tank, it's not a proper storage tank. If you think of the picture of Marina Coast, shows that nice 5 million gallon tank. This is like a 16,000 tank that's really just a clear well for a pump station that we replaced because we needed about 3 times the capacity. And after we replaced it, which I'll show you those pictures, we went and demolished that, and here's what the inside of it looked like. We didn't take this out because it was out of service, but this is just to give you an idea of what just normal use does to things. Okay, so then this is the work we had to do to replace those tanks, all this infrastructure piping, below grade, all your pipe tie-ins, below grade. You know, if you think of a water system, probably 30% of the water system you might be able to see above grade, and the rest of it is in the street. And that's, you don't have to quote me on that number, but I mean, there's an awful lot of the value of a water system is sitting underneath the pavement. So a couple more tanks. Another piece of pipe, fine, old wrapped welded steel with kind of a makeshift strapping. If you ever think about pressure, water under pressure, pipes under pressure, you get things running at about 150 pounds per square inch. Well, on a little 1-inch pipe, that's only about, if it's 1 by 1 inch, 150 pounds per square inch. You see, that's 1 square inch, so that's 150 pounds. That's not a lot, right? But now talk about a 12-inch pipe or something like that, and you're talking about several tons of force trying to blow that pipe apart. And it's not pretty when one of those things blows open. It doesn't hurt anybody really, but it blows open, and you have geysers, and those aren't good because you lose a lot of water and wash out a lot of stuff. And I'm being facetious. You don't want the pipe to blow open. So anyway, so you always have some kind of restraint system to keep the pipe from moving on you. And sometimes when the pipe got installed underground 40 years ago, they didn't put the restraint system in because it was just a long straight pipe, and they figured it didn't matter. And then somebody came in and put a couple of 90s in there and figured it must have been restrained, and it really wasn't. And then you go turn the water on, or you go to work on something, and it budges, and all of a sudden you're standing knee-deep in water, racing around trying to find a valve someplace. So things you have to think about when you go in and replace stuff. The other things you have to think about is all this stuff that wasn't shown on the drawings, all these electrical connections and a surprise pipe below grade. Just price of doing business, and obligatory paint job, new support. These aren't complete. Another one, a treatment pond with some corroded piping. This is just iron sludge that gets removed if you drink water on the Monterey system. This is the water that gets pumped out of the Carmel River, since we don't take it from the reservoir anymore. It gets pumped out from below ground, and in the process it gets to pick up a whole bunch of iron. And so they have an iron removal plant. This is totally, it's not hazardous, it's just rust, powdered rust basically, but it makes a mess of your pipes. So anyway, so we had to do a quickie makeshift replacement. This is flexible rubber, and that's PVC, and this is ductile iron, so that'll last another 20 years, hopefully, until we figure out something else. Sometimes you have to put in this is a backflow preventer. Sometimes you have to drop in an expensive piece of equipment because our standards of what health departments require and what are the standards of protecting public health and ensuring public safety fortunately keep getting a little more strict. And this is what's called a double check backflow preventer, and this was a line that was it's used as part of the treatment process, but it's connected to the potable water system. And it's about 99.99% safe without that backflow preventer, but that backflow preventer makes sure you don't even have to worry about that 0.0001%, that you're never going to get water from the treatment plant side when somebody's washing a filter and with some chemicals or something. There's no way you'll ever get that back into the potable water system. So sometimes you have to do that. This is some trench work right on the side of Jim Moore for the Aquifer Storage and Recovery Project. The pipe we had to tie into wasn't installed that long ago, but somebody decided it really needed to be deep. And just to give you an idea, when you're that deep, concern the contractors and the engineers too, but the contractors, it's their responsibility. You have to make sure you're not digging a mass grave. And I don't say that jokingly. A number of people have been buried alive in trenches. And so you've got to make sure when these pits are dug and the trenching's done that you have enough, you either have shoring installed or you haven't, it's laid back at enough of an angle so that if something collapses, the person's not going to get buried alive. And there are very strict regulations on that. So So that's what this bench is here. So that it's actually a safe trench for somebody to be standing down in. And this opens up much more. You can see it's a much wider area to work in. This is right along the side by the Seaside Middle School. And we actually, if you remember, when you were here, remember the blue striped pipe along General Jim Moore? We actually found a way to reuse this. We used about 600 feet of it. They saved it in the, I don't know if the Water Management District or Cal-Am saved it in their yard, but we reused about 600 feet of that on this particular project, just so that it wasn't wasted. This is that aquifer storage recovery project. Again, got a 700-foot well down in the Seaside Aquifer where you can pump Carmel River water, well actually potable water in during the winter season, treated potable water in during the winter season, and then recover it in the summertime. So that's why you have all this fancy two-way piping, so you can go into the well and out of the well and regulate the flows. And that's the other one. So there are 2 new wells there by the Seaside Middle School and 2 the other side. And I want to make sure it's enough time for Paul to talk. This is not anywhere from around here, but I threw this in just as kind of an infrastructure comment. We have really high standards, and water quality, pressure. You just take for granted that you're going to have water pressure at least 20 psi at the tap. Anytime you turn the tap on, it's never going to be dry. You're always going to have water. And when they need it for a fire, you're going to have it at 1,500 gallons a minute to 3,000 gallons a minute at the hydrant. 24/7, rain or shine, earthquake, whatever. That's what you pay for. And it's going to be tested and bacteriologically safe and all that stuff. Very high standards. This is in a country in Central America, one of my favorite countries. Here's a bridge that used to cross the river. Now it doesn't. And take a look at that. There's a little pipe right there. We are a little closer. Now it's a nice little place to have a picnic or a date or whatever. Here's one of the water pipes that was going across the river. And that's the way they decided to fix it. Okay. No shutdown. Maybe they didn't know where the valve was. I don't know. It's a little 2-inch pipe, and they just bent it over. It stops most of the flow. It didn't stop all of it, but that was okay for them. Rather than cut it and put a cap on or remove the pipe altogether, it's not serving anyone. That was about the bridge got washed out about 4 years before I took this photo. So they're obviously not in a rush. There was another little leak there, and they just but it works. It's okay. I mean, there's a good water system in that town. I even drink the tap water. Anyway, and then this is in Argentina. For those of you who speak Spanish, you can read it yourself. The polite translation in English is, here too the nation grows. And then underneath the graffiti, and screws the countryside, or screws the scenery, is the way it's used in Argentina. So, obviously, here's the government bragging about their infrastructure project. They put in a water project. They're putting in road projects. They're putting in all kinds of stuff, and they're waving the flag, and we're doing great for you. And not everybody is in total agreement. And then, have you talked about stormwater yet?
Yeah, we talked about it last time.
Okay.
Feel free to.
Okay. Well, did you talk about the outfalls at all? About the okay. So you're familiar with these? Yeah. I just threw that in. If you hadn't, it was going to be foreshadowing for when you talk about stormwater. And then the point is, here somebody had a design that they just figured this is going to work. The bluff is always going to be there. Remember, the deal was they built these outfalls to dump the stormwater out in the ocean from Fort Ord, and the bluff ended right about here. And they chose a perfectly good building material. This concrete cylinder pipe it's really good pipe. I mean, it lasts 100 years. It really does. But it only lasts 100 years if the bedding and backfill stays in the same place. I mean, and this stuff is really fabulous stormwater stuff. It's used all around the world, and it's just great. But when the bluff washes away and it's all sand, then wherever the end of the pipe is just starts undermining it, and this was working its way up to undermine its way right underneath Highway 1, and there were 4 of these. So this is kind of you don't want to be the engineer who somebody calls after this project, you know, just to give you an idea. This is another one of the outfalls here. Yeah, so this is the 60-inch. Nice 5-foot. It's great. It's perfect pipe. It's just nobody ever thought that the waves were going to take the beach. So we have standards for infrastructure, and then sometimes we hope that we kind of estimate how those are going to go in the future, but sometimes we don't always do it right. So, okay.
Thank you.
That's me. One other thing, 2 books that I would recommend, just from a water supply and infrastructure standpoint, which one is very local, and I recommend it just because it's a great history. I don't necessarily agree with the politics or the whatever. Ray March, it's titled A River in Ruin. It's about the Carmel River. It's a history. It's just a really great history of Carmel, Monterey, within the context of water and development. And he tells a great story, and the water stuff, we could go on for months about the politics. But it is a very interesting read if you're from around here and you want some history. Then another one that is just a must read if you're interested in water in the West. It was published back in the 80s. It's called Cadillac Desert.
Yeah.
You may have heard of that. It's by, the author has passed away, Mark Reisner, M-A-R-C, Reisner. And it tells a great story. Read it. We can talk about it for ad nauseam. So, thank you.
Okay. Thank you. Thank you everyone for having us out. Appreciate it. I learned a lot from these 2, and I work in the water district. It's always good to get more information. Tonight, I'm going to talk to you about our water production, our water consumption, and our conservation programs at the Marina Coast Water District. I have some information on how much water is actually pumped and where it comes from. And it ties in perfectly with Director Lay's presentation previously. And then I'll talk a little bit about the 5 or 6 different programs that I run at the Marina Coast Water District. So here's our 2013 well production. It ties in with what Director Lay was showing you up to 2012. This shows the 8 different wells that we have. In 2013, we produced water out of 7 of those. One of them was down for maintenance. That's well number 30 there in the middle. And this shows the acre feet of water each one produced during the 12-month period. This water comes out of the Salinas Valley Aquifer. Our wells are primarily on a plateau out at the end of Reservation Road, just as you leave Marina. You may be familiar with Reservation Road, where it goes along the top of the plateau and then it drops down into the Salinas Valley, down where the lettuce fields are. Most of our wells are up on the plateau. The newest well, Watkins Gate well, at the very end there, is down at the bottom of the hill, the level of the Salinas Valley fields. We are starting to produce more water out of Watkins Gate because it is the furthest from the coast. And some of our wells that are nearer the coast have potential for drawing in the seawater, which is what we don't want to do. So as we pump more and more from our easternmost wells, the safer we are. And we protect the aquifer, and we don't draw that, we don't exacerbate that problem of saltwater intrusion. 4,431 acre feet of water was produced last year. So if you can imagine an acre, let's say this turf area out here is about an acre. If you can imagine that area, 4,431 feet deep, a column of water, over a mile, well over a mile high. All that column filled with water. That's how much water goes to the marina and the Fort Ord areas in 1 year. Well, that's what's produced. Here's a production by year for the last 4 years. Shows an increase in 2013. I'm not sure what that is. I haven't really looked into it. I have a feeling it may be meter accuracy. Since we started pumping more water out of the Watkins Gate well, we have new meters that record the production figures at that well, and they may be more accurate than the wells that were used in previous years. Also, we had a very dry fall. As you know, we're in this period of drought right now. People were landscaping and watering their lawns and stuff well into the winter, and so that required us to produce more water in the fall, which led to these higher numbers for 2013. And this shows the water production by month over the year for 4 years. And again, if I use the pointer here, I can show you in the fall here, well, actually it started in the spring. Our production through February, March, and April was higher than the past 3 years, considerably. That's a lot. And then in the fall, you see over here in this part, this is the late summer irrigation season going in to the winter.
What was the spike in 2010? Do you know, is that something in particular?
Summer spike.
2010, I don't know. I think it was the first year of the golf course, the Bayonet Black Horse golf course, on potable water. That may have contributed to it. The first year we put them on, they started pumping around this time of year. April, May. We put them on potable water, and we had to meet that demand for the golf course, whereas in the past we didn't. So that may have contributed to it. 2010 wasn't a big construction period, so I don't think construction had anything to do with it. I would guess the golf course. And then what they did is we helped them by showing them how much water they were using on the golf course in 2010, and they did much better in 2011, 12, and 13. So that's probably why it's down here in these years. And then this is like a slide Director Lay showed you. The share of production between the service areas of Marina and Fort Ord. Fort Ord uses a little more water than Marina. In 2013, some of that is the golf course. Stays pretty consistent throughout the years. And then for the whole district, this is an estimated water use. And it shows where the water goes. For our single family and our multifamily accounts, I have a number here, it's about 7,200 accounts for single family and multifamily. For commercial businesses, it's about 230 accounts. Industrial, we have 3 industrial accounts. They're over on the Marina Airport. They produce fire alarms or something like that. And then landscape and golf course irrigation there. 203 landscape meters in our service areas. It's everything from small little parkway strips to the golf course, the largest landscaping site we have. And at the Water District, I run a number of programs. One of them is our public information program, doing activities just like this. Get out and speak to people about water conservation and saving the water. The public information program has a lot of different facets. It's everything from putting in billing inserts into the mailers that go out to our customers every month, billing messages, comparative use data like the charts we showed you. I pull the data about consumption and production and display that to the public when offered opportunities like this. We have a district newsletter. E-flyers are becoming more and more popular. They're easier to do. They're cheaper than sending out things by mail, so we do a lot of e-flyers. With everyone having smartphones now, It seems to be an easier way to get information out quickly. And then we have the public information booth, which is shown here. This was out at, I believe, one of the farmers markets in Marina on a Saturday or Sunday morning, where customers come up and talk to me about the different programs I have. We have a website, and then as you received tonight, there's one individual, I believe this gentleman. We have handouts for you here. If you want to grab one before you leave.
Oh, yeah, definitely.
We hand out free water conservation devices to help our customers save water. I help customers out in the field, whether it's residential, like this woman's house, or commercial business, or even the university. We do site visits. I take analysis of their water use over time with me, and I can talk to the customers about how much water they're using versus how much they probably should be using. And then I can help them adjust their irrigation timers, like this woman. She put in a new timer to help her conserve water in the landscape. I can talk to people about their old toilets and replacing them with new toilets that use less water, or whatever it may be. Probably about 200 to 250 visits a year. Some of the customer assistance is I'm able to do over the phone. I don't have to actually visit the customers. So I can get some of my conservation public assistance out over the phone. Our leak and high water use detection program is great. It's now with the new meters we have installed, we can record the water use at a particular site and then play it back, and we can see what customers did over a period of time. We can put it in charts and graphs, like Lizette is showing here on her desktop. And we can help customers by looking at their water use and sharing it with them. I can email it to them. I can send it to their smartphone, and then we can talk about their water use, what it is and what it should be. The guys out in the field are great. Our crews are out in the field all day long. When they see something, they can call me. Leaks visible leaks don't last very long because we can catch them quickly because it's a small area. They help out, they replace meters, and they search for small leaks, even the big ones in the distribution system. I could stay busy all year just on leaks. To give you an idea how much work there is for leaks. It's if we really wanted to crank up conservation, we would probably go for leaks. That's the easiest way to conserve water, is finding those leaks. There's not enough time in the day. They're everywhere.
You're talking about leaks in the distribution system or leaks on the customers?
Well, I primarily work with leaks after the meter.
Okay.
Yeah. Whereas the operations and maintenance handle the big leaks.
Yeah.
And some of those are unknown. In Fort Ord, you know, it's the infrastructure in Fort Ord is pretty old, and although our leak rate is not all that bad, it's much better now that we've had some control over Fort Ord for a number of years now. We've really reduced the leaks in Fort Ord by just abandoning areas like the old dormitories and those buildings. We just cut them off, and we could just see the water production just drop when we cut off neighborhoods. So that really helped out. And then a lot of the new infrastructure is helping out too. We're replacing the old mains, like out in East Garrison, those type of areas. We use those service lines. We can determine if there's leaks now and repair what is needed to be repaired. And then for new businesses, of course, they get all new plumbing, and we abandon the old stuff. We have an in-school water education program. Most of this is contracted out, but it is a great program, probably one of the best in California. We were one of the first to do it as well. We hire musical performers to go out to the schools and teach the kids about water conservation. And then we have an in-school water education teacher that goes out to the schools 3 times a year and teaches the children about water conservation and water science. 1,300 to 1,400 students and 60 to 70 teachers in 5 local schools. It's a great program. Kids love it. When I come to their houses to help their parents, the kids pop out of the bedroom and say, We learned about water conservation in school. We have our rebate programs, the high efficiency toilet and clothes washer program. For those of you that live off campus and purchase a high efficiency clothes washer, we can help you with that. PG&E also has some money. And then toilets. Replacing toilets is big, especially in our multifamily housing. A lot of the old multifamily units around here have old toilets. And by upgrading, we can reduce the consumption by 20% or more. And we help pay for that with a rebate program. We also have incentives, money for upgrading your landscape to use less water. Primary thing with automated irrigation is getting these new timers put in for our large landscape sites. They automatically adjust how much water they apply based on the weather, and then they automatically turn on and off based on either soil moisture or by rainfall. It's really nice, and it's a great way to save water. I would say 20 to 30% on those sites, almost immediately. And then the second photo on the right shows a home that had a lawn, and they eliminated the grass and put in low water use plantings on drip irrigation. And I believe this site received about $600 to help with that work. They put in this patio too. This was part of the lawn here as well. So it's a great upgrade. More colorful, less maintenance, and less water. They probably reduced their water bill probably by $40 a month. It was amazing how much water they were using. So just by changing over to drip irrigation and low water use plants, they saved a lot. Okay, thank you very much. Appreciate it.
Do you want to show something else, Peter?
Huh?
Did you have something else to show you wanted to show?
Yeah, let me. I have a question for you. If you have to do service learning hours, here is the project I propose. You can do it next year. This one is the app for the cell phone from Colorado. If you can modify it for you, the Marina Coast Water District, it's a good project. To track water use, stuff like that. So if you can consider as your, maybe a class project or capstone, modify it for use here. It's a good project for you.
Yeah, really good idea.
Yeah. Okay. That's all I have.
Oh yeah, thank you, thank you. Well, so do any of you have questions for any of our presenters? I certainly do, but I want to give the floor to you to ask your questions. Hey, Joseph.
You can go.
Just a general question. I live in a apartment, so I don't really get a water bill. But I was wondering, does like electricity, does like when your usage goes up, do they charge more, or is it just a flat rate for the water use?
So is it tiered kind of? Is that
tiered? Like the more water you use, the more expensive it is.
Yeah.
Okay.
Yeah, we have about three tiers. And we adjusted the first tier. It meets most household needs. So those households that conserve water stay at one rate. And then immediately after the average household, if you start to use a little bit more than the average household, you do get dinged because you go into the second tier. And then, of course, the third tier is for excessive use. I do see a lot of homes with automatic irrigation systems in the third tier. So primarily, most of the water that gets people into the second and third tiers and the higher water bills is automatic irrigation.
I could just add to that, there are some, we're very progressive here on the Central Coast because water isn't quite as abundant as in a lot of other places. So we have tiered rate structures and just about everybody has a water meter. But there are a lot of water systems throughout California that don't have meters. The Sacramento area does not have, you just pay a flat rate because it costs money to install meters and maintain meters and to read the meters and the bill according to usage, and some water systems just cheaper in the short run for them to just bill a flat rate. So
Around here.
depending on where you are, you might just be able to use all you want. Yeah, which is, presents a problem when you're in an unprecedented drought situation, because the water utilities have a really hard time knowing who's using all the water because there's no way to measure it.
Yeah, our tiers rates only affect those customers that receive water bills. In our area, we have a big problem with multifamily housing. Because we have the university and we have a large population that live in multifamily units in Marina, those customers don't directly receive the water bills. And as a conservationist, that's difficult for me to deal with. Those customers sometimes may use more than the average because they don't really feel directly, they don't feel the monetary punishment. They don't pay the bill directly, so they don't have a tendency to conserve as much as those who do receive a water bill.
Just add one thing, just because it's very apropos for this moment. If you read, people read the Herald at all, not the Herald? Sometimes, maybe, okay. There was an editorial in the Herald just this weekend that addressed this, and this month's American Water Works Association Journal has an article on exactly the same thing. You understand that the way water utilities pay for all the stuff they do is through their rate structure. When you conserve water, if all of their rate structure is based on how much water you use, and you use less water, there's kind of a problem there. The water utility would like to reward people for using less water, but in a drought, when everybody uses less water, they run into a problem. They lose money. And they don't have an option of going broke, because they have obligation bonds. If they're public system, they have to pay, public or private, they're in debt for a whole bunch of money, and they've got to keep making that debt payment. And so the ratepayers, somehow they have to recover that money. And so often what happens in a drought situation, you do a great job of conserving, and what you find is your water bill goes up. Well, that's not any kind of a conspiracy. I mean, it happened in the '76 drought, and it's going to happen to, it may happen to people around here, we hope not, but I mean, that's one of the problems with having to pay for all the infrastructure.
Zach?
I was wondering if you could talk about the different kinds of pipes or like the materials that are used to make it, because you were saying.
How much time do you have?
Or just like just a general overview,
okay.
I guess.
There are, for water distribution systems, I mean, there are all kinds of pipes you can use. Just about any material you can imagine. You can use copper, you can use steel, you can use cast iron. Cast iron isn't used per se anymore. Plumbing, what you see, residential plumbing is slightly different than what you see underground. So you can go to the Uniform Plumbing Code and look at all the different pipe materials and everything for building construction. Stuff that goes underground are materials that go underground are a little more specific. You can use steel, and it's usually wrapped with some kind of like a plastic wrap or a asphalt type wrap. So they're wrapped steel, but it's welded steel pipe where the joints are welded on, and it has all kinds of advantages. Again, I could go on at great length on this. So welded steel pipe. Another one is ductile iron pipe, which is, it's very much like cast iron pipe, but it's an advanced form of cast iron pipe. A lot of the stuff I showed there was the black stuff was ductile iron pipe with the flanges on. Very strong, very long service life, very heavy, very durable. It's analogous to steel. You can't weld onto ductile iron because it's essentially like cast iron, whereas you can weld on the steel. Steel has corrosion issues. Ductile iron is more resistant to corrosion. Another very popular material around here is just PVC, and it's known affectionately by all the people in the district, by all the people in the business, pretty much as C900, which is the American Water Works Association specification for PVC that's used for potable water systems. It's blue pipe, and it's very reliable, corrosion resistant. You don't have to worry about it rusting, but it's very flexible, and you can bend it a little bit around, occasionally bend it to fit if you need to. People love to use it because you can cut it and fit it just like PVC pipe in your house. And
generally lower cost, installation cost, and actual material cost. Then there's HDPE, high-density polyethylene, which is that blue stripe pipe that I showed. That is this wonderful flexible stuff that is great, like if you're going to do trenchless technology, where you're going to directional drill and then pull a section of pipe, drill, you know what I mean with directional drilling? Instead of cutting say I want to go, well, across General Jim Moore, we had to put a power line across General Jim Moore Boulevard, and it happened about a month after they just finished paving it and doing all the curb and gutter and doing everything just beautiful. And now we're looking at digging a trench right across. It doesn't go over very well. So, and it was just a little 4-inch piece of power conduit that we needed to put through there. So there's a technology now called directional drilling, where the drill bit is governed by basically a GPS locator. There's a locator on the drill bit, and there's somebody walking along the road. So you paint a line where you want that drilling to go, and the guy's sitting back here on the drill rig, and he just kind of threads that thing right down and pops it up on the other side of Jim Moore, and then you pull the pipe back through with the drill bit, and you didn't have to cut an open trench, and you go 20 feet below the roadway, and it's used lots of places for great big pipes and little pipes. So,
is that like a remote control?
yeah, the guy's controlling it here. You know, kind of like the control on a airplane, model airplane or something like that. You know, kind of driving the bit, and it's remarkably accurate. I mean, I was just amazed. I'm standing there, the other side of Jim Moore, and here it comes up, and it was about 6 inches off the stake that we put in here. So, yeah. So that kind of pipe HDPE is sometimes used. In this case, we just pulled PVC through, but it's very flexible. The disadvantage is that it has to be field welded. It's plastic, and then it has to have, you have a special heat sealing machine that you prepare the surfaces, and then you heat, you put them together, and then you heat seal it and actually form a fusion weld of the plastic. It's got to be done under the right conditions and a skilled person, and so it's not quite as easy as just bolting up PVC, but you can put in long stretches of it and big diameter. It has some great advantages.
Is there a lot of R&D that goes into that kind of stuff, developing? There's
people are always working on new pipe formulations. There's a lot of inertia, and I don't think it's a bad thing, but when you're talking about getting a pipe certified, getting civil engineers to say, I'm going to specify that pipe in a design. If I'm going to write that specification and have my client spend, $500,000 putting in this pipe in here, it's not going to fail in 10 years. I mean, I'm going to make darn sure I'm going to use something that's tried and true. And so if you come out with this pretty blue stuff made out of, or I'll use a different color, this pretty polka dot stuff that's made out of recycled paper, and everybody thinks it's the greenest, coolest, wonderful thing, but it's only been in, you can't find anybody who's tested it for more than about 6 months. Nobody's going to use it. I mean, so there's a certain inertia. Things have to be rated and meet specifications, and they have to be tried and true. And so you'll find people sticking with things like PVC C900 and ductile iron and HDPE. People sometimes are cautious about HDPE, even though it's been around for 25, 30 years. But yeah, I mean, people do work. And you can get different kinds of linings, and you can get different heat treatments on it, and you get different sizes depending on the pressure class. I could go on.
Peter brought this up, but how would CSUMB students encourage administrators to reallocate our water budget for places like Seaside that are using it up so much? Or
I mean, you can send an email to President Ochon, and you said you attend a talk, and you know that you have 600 acre-feet per year unused, and you propose a list out, say whatever.
so it's Ochoa who would have that authority, though, or
yeah,
you
said you can lease that for maybe a couple of $100,000 a year for 20 years, and that you get a couple of $1 million. You can propose whatever you want to do, maybe upgrade your computer system or whatever. do a field trip or something.
Why wouldn't they want to do that? I mean, is it just fear that we'll never get them back, the water rights back? Is there...
You know what, yeah, that's what they're concerned, but if you sign the contract, you lease only for 10 years, you know, by the end 10 years, you get it back at 20 years. But, you know, they still have the mentality that, you know, it's my money, I don't want to give my money to everybody, but, you know, that's a resource, right? So you have that 500 acre feet per year in your bank, you just leave it there and they couldn't produce any revenue and you just, you know, you're entitled to that and you just hold it, you know, and you couldn't do anything because I look at the CSUMB master plan for the next 50 years, I don't think they ever use that on that water. They can, you know, look ahead 50 years, the university is still not fully developed and they may go up to 700 acre feet and still just waste a lot of resources, you know.
Did CSUMB have the second largest allocation?
Yeah.
Was the Army was number one and CSUMB?
Yeah.
Really?
Yeah.
Wow.
But you know, you look back years ago, right? Say 15 years ago, right? Everybody fighting. Oh, I want a lot of water for myself, you know. CSUMB that time. Oh, I have 40,000 students, you know. I need a lot of water for me, you know. But now, what? By the time you get to 25,000 students, that's what? Maybe 50 years from now, you get up to that level, and you know. So why don't you? You know, right now, right, they increase your tuition every year, right? Is that, we don't have money, right? We have to increase tuition and all the charges to you, right? And they have the resources just sitting there, not used. So it's up to you, you know, you have to propose, and that, you know, okay, you know, you lease that, you can get a couple of $100,000, save you, maybe reduce the fee or services for yourself and the student. You know. Much better than you just leave it there unused.
But if oh, go ahead.
I have a question about my neighborhood back home is trying to change our septic tanks within our homes into the city lines. Like, what does that entail? I wonder why the city's pushing for everybody to change, because I feel like at home we use less water because we have a septic system.
Which area?
I'm Central Valley, Toledo County.
Yeah, because you know, the whole purpose is because the septic tank will pollute the water, underground water, right? And then it's, you know, it's not as good that you have a wastewater system where you flush, you know, and they treat it and recycle it, you know. So that's the main idea. So you know, you have to apply for you know, permit from whoever, the city or district, and connect with there. You have to pay the connection charge and the monthly charge, and you have to abandon the old septic tank. You get a permit from county health department to abandon the old septic tank. But the whole idea is to improve the contamination pollution.
This, the city of Marina was septic tank back in the old days, so it's a good example of a city changing to sewer. They would have to put the main distribution pipe to take the sewer to the treatment plant in the streets in a grid system. And then each individual home, they have to run a single pipe into the house from that distribution, from the curb into the house, and then make the connection. And they just go down the street, connect the first house with a single pipe, do the next house, house after house after house. And they do it in quadrants. You know. It's a lot of work. It's a lot of trenching.
It's a lot of money.
It's a lot of money because you have to break up the old streets and
What the benefits are for,
Water quality.
okay.
especially in that area.
We, we're gonna talk wastewater,
Yeah.
but there's another, I was going to address on-site systems and some of those issues. We can talk about that more, but that's a whole other,
Right.
topic.
The sewer system works pretty simple because
Yeah.
most of it's gravitational. It flows right out of your house and gravity takes it most of the way. Not all the way. We do have a lot of pump stations that boost it and push it on. but it's less complex than the water distribution system going to your house.
So in that first slide, you were showing the valve that was sealed up, and you were saying that you had to take 2 other valves to shut off that section. So was that valve that you were replacing one of those other valves that would have been shut off? Like, is that the same kind of valve that you were replacing, or was it something separate?
In theory, you've got to shut both ends of the pipe
Right.
to get it dry.
Mm-hmm.
You've got to somehow shut that pipe down. What the function of that particular valve was, I don't know, because like I said, that particular project, they just asked me to come down and do the documentation, the drawings, and inspection, so to speak. But remember, you have this whole network of pipes, so having that one valve there may have enabled them to then divert flow off through another section of pipe. This is also that they can manage the moving water in 2 different directions. You're coming, right now they move water from the Carmel River up to serve Seaside some of the time, and then they pump out of the Seaside aquifer some of the time and pump it this way. But when whatever comes online with the coastal water project and distribution system, then there's going to be a net flow of water moving back down towards the Monterey Peninsula, so it's going to have to go different ways, and this valve was enabling them to do some other work someplace else in the system.
And most distribution systems for water are designed in neighborhood loops.
Mm-hmm.
So sometimes you can shut off one line, and there's enough water can access that neighborhood from another location or another direction.
Yeah, ideally you've got that
Yeah,
kind of situation so that it's less friction on the system.
So sometimes you have these dead ends. There's just a pipeline that goes out to a community, and if you have to work on that pipeline, you have to shut off the whole community.
Yeah.
So my name's Tyler Belko, and I was you were CC'd on an email sent to me by Shelby Rogers, Paul, about a conservation program here on campus. And so if we implemented one of those on campus, there would be even more reason to reallocate water from CSUMB to other cities, because in theory we'd use even less water.
There's a lot of, I believe CSUMB has a lot of, conservation. CSUMB can reduce a lot of water consumption.
A lot of room for improvement.
Okay.
A lot of.
Well, because this is something I'm actually interested in, and I'm in student government right now, and I'm probably going to be next year, and so.
Yeah, with
I agree
the
it's a
older
thing.
buildings, it wasn't Shelby, but my recent intern Laura and I went out to buildings 205 or 202 through 205, and I think it was something like we calculated they could probably reduce their use by 40%.
Okay.
Wow. A lot of that is probably showers.
Mm-hmm.
So that's probably the number one thing in a dormitory type building is getting people to take short showers. You take a huge chunk of water off right there.
Okay.
And then the toilets. Because they're old dormitory buildings that were built probably in the last upgraded probably in the 80s, maybe in the 70s, they have high flow toilets and they can be reduced considerably.
So you can propose for that down, right? Say you reduce 40% of water consumption, right? So you reduce 40%, whatever the cost of that for water consumption, and the reduction there you can spread and reduce your rental, your fee there.
Yeah, considerable cost savings. We're talking thousands and thousands of dollars a month. Yeah, I can't imagine what the water bill is at CSUMB. It's probably a lot. You know, I'm guessing, just a guess. I have no idea.
And then
I would
does
say
this?
$350,000 a month.
And then does CSUMB include East Campus as well?
Well, when we talk about CSUMB, yeah, we're talking.
Okay.
But sometimes we separate the two.
Uh-huh.
Conditions are a little bit better on the main campus than out there.
Okay. East Campus.
It's a different type of use too.
Uh-huh.
You know, that's residential where people don't receive a bill directly.
Mm-hmm.
This is more of a commercial what do we call it, institutional
Okay.
usage here. You don't have, your time on campus, you don't have a faucet within arm's reach. Whereas when you live out at East Campus, or East Campus, you know, your faucet, your shower's right there, people are using water constantly.
I was just wondering, do you ever go around on campus and look for leaks or anything?
A lot of our leak detection is done by computers or by meters. No, I haven't. We kind of let the facilities at CSUMB handle their infrastructure.
He's coming in a few weeks, but he's going to be
Okay.
talking energy.
So I found it from home.
No, the facilities crews here handle that type of stuff. Yeah, it's like its own little entity here, its own little city, and they have their crews that handle that.
You know, for other district, they have an app here, and you just take a picture and hit and it sends the information to the district with the location, the link in the picture. So that's what happened.
Yeah, if you know of any of these, just give us a call.
I always email
Yeah.
facilities.
Yeah, I had a question. It was pertaining to the replacement of like the water systems. Since the workers are out there like around midnight time, how long does that process generally take, and how long are like the workers out there?
Okay, that was one example of one particular project that was done because it was in a traffic control
Yeah.
area downtown, so that's why it was, at night is a big main.
Yeah.
A lot of distribution system work, replacement work is done in broad daylight.
Okay. Yeah.
It just depends on, and it's, you know, typically you try to do it during an 8-hour shift. Ideally, you do it, if you're in a residential neighborhood, you schedule it during a normal workday because people don't like having jackhammers and saws and things going at 4 in the morning. You know, it really
Yeah.
gets people upset. So you try to start work, you get the crews on site between 7 and 8, and then you start making noise. As you know, try not to make noise before 8, and try not to make noise much after 5. So that's the ideal time to get the work done. But when you have downtown situations, it just makes more sense. You know, rather than have to direct people around the whole boulevard.
Right.
That was, I think, right off of Fremont, in front of the fairgrounds.
Oh, okay.
But that particular one was driven by having demand low enough at night so that they could shut the main down at night. They had a window that they could shut the valves off.
But for emergency, you work all night. There's one case I know actually it happened right at the Christmas Eve, 6 p.m. It blew up the whole street. And then people have to walk through Christmas and major problem. So depends.
Yeah.
The crews work very fast. It's amazing. You know, probably the prep work and the finish work took much more time than actually fixing the pipe. Yeah, the guys get right in there, they cut it, they throw in a new pipe in an hour or so. You know, it's like it's nothing. But it's all the other work.
Yeah, and you want to, you'd much rather go in on a planned shutdown.
Yeah.
You want to go in this situation where, we know we're going to shut it down at this time, and the pit's going to be essentially dry except for the water that we know is going to go in there. When you've got to go in there and a 12-inch main blows wide open, that's a whole other thing, because by the time you get there, you've got a street full of water, and everybody's mad, and the fire trucks are running around, and the news people are there trying to, and it's a whole circus. And then you've got to get in there and get the water out and get somebody out of bed and get the backhoe down there and start digging. And so, yeah, you really want to do this when you want to replace stuff before it blows up.
You know it's going to fit.
Yeah, you know it's going to fit. You get it done.
So sometimes something will blow up and you don't have the parts to fix it.
Yeah, and then you've got to do something just
it's
work
up in San
around.
Jose somewhere.
Yeah.
Yeah, that's the problem.
Yeah.
Would you say there's enough manpower out there to replace this stuff at the rate that it's kind of deteriorating?
Oh, there's enough manpower. But it's all about money. Yeah.
And most taxpayers, well, I'll try to, I gotta stay off the politics. The general consciousness is most people are absolutely denial about the infrastructure debt that we have in this country. I'm just talking about water systems being $1 trillion. Roads, towers, bridges, it is huge. And it's something that professional engineering organizations have been trying to get people to be aware of, and it hasn't really gotten a lot of attention. So, yeah, it's not about having enough people. We got a lot of skilled people who can do the work. It's about willingness on the. It's going to cost everybody a lot of money, and it's going to be taxpayers or ratepayers, or most likely going to be a combination of the two that are going to pay for that. And it's whether, as a nation, we feel it's important to have a really good, solid infrastructure, or just maintain what we've been living off of for the past 100 years, or whether we think it's okay to kind of let it deteriorate. Anyway.
Yeah, much of the system, you know, above 90% is perfectly fine, and will work well for many years. So it's just, there's no need to go out and replace massive amounts of it at one time. But it gets replaced in sections.
Yeah, if you've got a 60-year life, you've got to replace about 1.5% per year just to stay where you are. So that's your cost every year to replace, and then there's a lot of stuff that is that's due for replacement right now.
Yeah, a lot of the unforeseen stuff is emergency breakdown stuff.
Yeah.
When something breaks, then sometimes you have to make the choice to upgrade it. More than just that one little valve, let's say. You say, okay, well, we're going to be in there, we may do this street, you know, or something like that. So big chunks sometimes, or small emergencies, end up replacing big sections of pipe or whatever.
So the cost to repair and upgrade the water and sewer system in the Fort-Dor area probably $300 million.
How much? 300 million?
Yeah, and then so you know, say if you look at the water system, what do you think the grade for the water system will be? It's probably D minus, and for wastewater probably E.
A D minus or a D?
Yeah. If you look at.
Yeah, they saw the Colbert report.
So you know, when you go to the next section infrastructure there, and you can see the grade, you know, the grade on the what the grade for the street and for the rail, for the water, wastewater, bridges, and you can see it real bad.
Yeah, our crews spend a lot of time on the sewer system in Fort Ord. It's really old.
The pipe, the sewer pipe you touch and it just collapses.
Oh, is it that old, is it they put on some of that old transite, or?